Assalamu alaikum. Welcome to lecture number 22 of Software Design and Architecture. I am your course instructor Fahad Anwar. So, students, before I start today's lecture discussion, I would like to give you a little bit recap about our last lecture. So, students, if you remember what we discussed in our last lecture, we discussed different categories of architectural patterns. In our last lecture, we have been studied data flow architecture, where we see two different variations of data flow architecture, where we see batch sequential based data flow architecture style and pipe and filter based data flow style. For both architectural styles, we see the architecture of batch sequential and pipe and filter style as well, and then we see possible domain areas or possible application areas where batch sequential and pipe and filter based architectural patterns can be utilized, and then we see some limitations and benefits of both data flow architecture for batch sequential pattern and pipe and filter based pattern as well. So students, it's a little bit recap about our last lecture, what we have been discussed in our lecture number 21. So students, let's start the formal discussion of our today's lecture, which is lecture number 22. So, students, here is a brief objective of our today's lecture discussion. In this lecture, we will also discuss different and other different categories of architectural pattern. For this lecture, we will see shared or data-centered oriented architectural style, in which actually we have two different types of data-centered oriented patterns. Shared repository will be discussed in this lecture, and another second type, black box or blackboard architecture pattern, which is another type of data centered software architecture, will be discussed in next lecture. So students, in this lecture we will discuss a data centered oriented architectural pattern, in which we see shared repository architecture in very detail. So students, here is a brief objective or agenda of our today's lecture discussion. So here are the different categories of architectural styles. So here is a little bit recap about our previous three lectures. So if you see here, layered based hierarchical software architecture have been discussed in previous lectures as well. Client server and service oriented architecture, which are basically two different categories of distributed software architecture, already have been discussed in lecture number 20. And then in lecture number 21, we also discussed two different categories of data flow software architecture, where we see pipe and filter and batch sequential data flow based architecture as well. So students, in the most left side, hierarchical software architecture, distributed software architecture and data flow architecture have been discussed very comprehensively in our previous three lectures, and now in our future lectures we will discuss remaining architecture styles. Now for this lecture we will discuss data centered software architecture, where we will discuss the shared repository architecture in this lecture, and in the coming lecture we will discuss a blackboard or a black box architecture as well. So it's a recap about our overall discussion about different types or categories of architectural styles. So students, our today's lecture agenda is about data centered software architectural style. So this data centered oriented software architecture is also called shared data architecture as well. Basically, data center software architecture is characterized by centralized data, which is actually shared by its all surrounding different components, and these components are should be independent of each other, and the software system is actually is decomposed into two different areas or two different partitions, and these two different areas or partitions are number one data store and number two are independent software components, which we also known as agents. So data centered or shared software architecture is actually partitioned into two different areas. Number one is data store, and the number second is independent software components, which we also known as agents. So the connection between the data module and software components are can be implemented by two different methodologies. So we can either utilize an explicit invocation method or implicit invocation method. So what are explicit or implicit invocation method? So these are the different programming terms you have I suppose here you are well aware about these two methodologies, explicit invocation or implicit invocation. You will be discussed in your object oriented programming these two terms as well. So students, data centered software architecture, we also call this type of data centered software architecture as shared architecture model as well. So in this type of data centered architecture, the software component actually does not communicate with each other directly, whereas you can say that all the communication between different components is actually being conducted through a data store. Because in our previous slide, data center actually have two different areas or partitions. Number one, data store, and number two is independent components. And these independent components cannot communicate directly with each other. Whatever the communication is will be conducted through a data store. So you can the shared data module provides all the mechanisms for software components where it can perform different operations like ranging from insertion, deletion, updation, and retrieval. And these are different types of operations which can be performed by different components, and these components cannot directly communicate with each other. Instead, they are actually communicate through via data store as well. So it's a brief background or a brief structure about a shared software architecture, which we also call data centered software architecture. So data oriented or a shared software architecture, basically the high level design solution which is based on shared data store, which actually we all centrally command through a shared data center, or which we also call a shared software architecture. For this shared software architecture or data centered software architecture, we have basically two broad categories. First one is blackboard style, which we also call the black box as well, and the second one is repository style. Students, in this lecture number 22, repository style of shared data software architecture will be discussed in very detail, and the blackboard or black box style will be discussed in lecture number 23. And students, what is a repository architecture? So basically, a repository architecture style is a type of data centered or a shared architectural pattern which actually provides supports user interaction for data processing as well. So different independent software component or agents of the data store control the computation and the flow of logic of the system as well. So students, you need to understand one thing: any data centered or that shared data software architecture has two basic components. Independent has two basic variations or partitions: number one, data store, and number two, independent components. And these independent components does not communicate directly with each other. All kind of communication will be conducted through data store. So we can also say that the data store control the computation of flow of logic of the entire system as well. So here is an example of repository architecture. In this diagram you will get better idea about how repository architectural pattern is actually worked. So students, if you see here, physician diagnosis, lab testing, pharmacy and drug processing, counting and administration, these are four different independent components. These four different independent components don't communicate directly with each other. For example, if lab testing want to communicate with physician diagnosis, the lab testing component will be communicated with the physician diagnosis via shared repository or a data store, which is a patient database system. So that's why these are not independent components. These components are always communicated via their data store. So in this example of repository architecture, you can see that patient database is actually a data store, and physician diagnosis, lab testing, accounting administration, and pharmacy drug processing, these are four different independent components, and these four different independent components don't cannot communicate directly with each other. All of these four components will always communicate it through a central repository, which is a patient database, and we also call this as a data store as well. So all data in a system is actually managed in a central repository that is accessible to all the components of a system. What are the components of our this system? Physician diagnosis is an component, lab testing is an component, accounting administration is an component, pharmacy drug processing is a fourth component as well. So in this diagram, basically we have four independent component and a one data store, and all of these four components will communicate with each other through a data store, which is a patient database system. So in short, we can say that components don't interact directly, only through the repository, which is actually is a data store. So data store and components are two basic partitions or variations of any data centered or shared repository architectural patterns as well. So repository architecture actually organizes tools around a repository in an efficient way, which actually helpful to store a huge or a big amount of data. So students, we don't need to transmit data explicitly from one component to another, because the reason is these all of these components are independent to each other. They are not dependent on each other, and all kind of communication will always be conducted via a shared data repository or a central database. So that's why we don't need explicitly or a clear type of communication, because we already communicated via our data store or a central database as well, as we discussed in our previous slide, where we have a patient database as well, and there are four different independent components, and all of these four independent components will be communicated with each other via central repository or a patient database as well. So however, we can say that uh, uh, these different independent components must operate around an agreed repository data model. So because data is centrally allocated, so there is a central repository data model is as well. So we can say that there is a compromise between, there are specific needs of each tool, and it may be difficult, or you can say that it is also impossible to integrate new components if their data models don't fit the agreed schema. So from this we can conclude that every independent component should be coherent with the data model of centrally repository or a shared database as well. So all of these independent component must be coherent in terms of schema with their centrally repository data model as well. So repository model, although it is sometimes impossible to distribute a logically centralized repository, because there sometimes we have problems like we can face in a shared repository, like redundancy problems, inconsistencies problem as well. So in practical examples where we actually utilize this repository architecture, sometimes it becomes very difficult for the developers to distribute the repository over a number of different machines in a some real world environment. So you can say that these are the different disadvantages as well of a repository architecture, like repository architecture maybe face some kind of redundancies, inconsistencies, and it may become difficult for the developer to distribute its repository across a different number of machines in a real world environment. So these are the different limitations of repository architecture, which may be need to faced by a developer in any real world environment. So here is another example of repository architecture. Here is a general block-based diagram. You can see that of a repository architecture, where you can see that the dashed line pointing toward a repository indicates that repository clients have full control over the logic flow. Here we have a three different agents, one, two to three, and you can see that these dashed lines which are actually pointing toward a repository, indicating that repository clients like agent 1, agent 2, agent 3 have full control over the logic flow. So here is a the term bootstrap is being utilized. So what is the bootstrap? As Bootstrap is basically is a open source CSS framework which actually directed at responsive provide as a first front end web based development applications normally utilized by this bootstrap, because this bootstrap contains different front end based web applications where is mostly it is commonly utilized as well. So you don't need to know about what is a bootstrap as well, so you just need to focus on the repository architecture here. The thing you need to understand is that here the dashed line which are actually pointing toward the repository, indicating that repository client like agent 1, 2, 3, these are different clients actually have a full control over the logic flow. So that's why in this diagram you can see that how a repository is actually worked among the different clients or a different agents as well. So you can also say that clients can get data from data store and put data in data store as well. Like different clients may have different interfaces and different data access privileges as well. All of the clients must have different privileges. Like in database के अंदर आप लोग ऑलरेडी ये स्टडी कर चुकी होंगे कि एक यूज़र के पास डिफरेंट टाइप्स की प्रिविलेजेस ग्रांट्स की जाती हैं, एक्सेस दी जाती हैं। हर यूज़र के पास सेम इंटरफेस कभी भी नहीं होता। लाइक मैनेजर के पास इंटरफेस और है, कस्टमर्स का इंटरफेस और है, ऑपरेशन मैनेजर्स का इंटरफेस और है, मेन मैनेजर्स का इंटरफेस और है। तो डिफरेंट यूज़र्स का डिफरेंट इंटरफेसेस उनको प्रोवाइड किए जाते हैं और हर यूज़र के लिए डिफरेंट प्रिविलेजेस भी सेट की जाती हैं। तो मोस्टली वहाँ पर रेपोजिटरी टाइप आर्किटेक्चरल भी यूटिलाइज़ की जाते हैं। सो we can say that like different users or clients must have different interfaces, and different data access privileges are also provided to different users in this type of architecture as well. So here is another example of repository architecture. If you put focus on this example, this is actually an example about IDE, which is an integrated development environment. So what is IDE? I am suppose that you are already well aware about the integrated development environment. Like you have different IDEs available, like NetBeans is an IDE, Eclipse is an IDE. These are the different integrated development environment. If you see in this example, actually what is it is being tells to us. Basically we can say that majority of systems that use large amount of data are organized around a shared database or repository, as you can show in this figure. This type of repository model is therefore mostly suited to those kind of applications in which data is generated by one component and used by an other component. Like you can see that there are different components of this any IDE, like UML editors, code generators, Java editors, report generators. Like code generator module will generate different types of codes, and this code generator module will be helpful to work by another component which is report generator, because data is generated by one component is actually used by another component in this type of architecture. So here is an example of integrated development environment which has different components like design translator, analyzer, report generator, Python editors, code generators. All of these are different components, and data generated by any one component can be used by another component. So example of this type of system mostly include like command and control systems, management information systems, like different CAD systems, and interactive development environments are also example of this kind of repository architecture as well. So in this diagram is actually tells us as a situation in which a repository might be used, like different IDEs use this kind of a repository where one component is actually where data is generated by one component is actually used by another component. For example, like code generate UML diagrams provide as a static or dynamic view about the system from where the developer team will get the architectural details about the system, and code generator module will be utilized the data generated by the UML editor component. So we can say that actually data generated by one component, for example UML editors generate the static and dynamic architecture of the systems, and these static and dynamic architecture will actually be utilized by another component, which is a code generator. So in short, you can conclude about this example is that in any interactive development environment, data which is generated by one component is actually used by another component. So it's a beauty of repository architecture. So this diagram actually shows that uh, any interactive development environment includes different tools to support model driven development, etc. Like the repository in this case might be a version control environment which actually keeps track of changes to software and allows rollback to earlier versions as well. So the most main point and important thing about this example of repository architecture is that uh, data generated by any one component is actually used by another component in this type of repository architecture, and all of these are the components like design, pattern analyzer, report generator, code generator, UML editors, and Python and Java editors. All of these are different components which are actually provided by any interactive development environment. And repository architecture, the data generated by any one of these components will be actually utilized by another component. For example, as I said earlier, UML editor component provide as a static view and dynamic view type of architecture to the developer team, where the code generator component will be utilized the UML editor component data as well. So in short, data generated by any one component in this type of architecture will be used by another architecture. So here is an interactive development environment example how an repository architecture is actually implemented in a real world. So here from, I hope so, in this IDE example you will get a clear idea about how repository architecture is actually being implemented in a real world environment. So here is another important aspect of repository architecture is the case tools. So there are many case tools surrounding the data store. So what are the case tools? Are basically a computer aided software engineering tools or are technologies that provide automated assistance for software development. Like the goal of this case tool is the reduction of the time and cost of software development and provide us the enhancement of the quality and the actual system which is actually being developed. So students, if you see in this case tool diagram, you can see that these case tools are actually surrounded by the data store as well. So these case tools can be provides different program scripts, menus, like static diagrams by the UML, different dynamic diagrams, different code generators as well, different forms, different reverse engineering techniques. So these are different services which are actually provided by these computer aided software engineering tools, which are actually surrounded by this data store or a shared repository architecture. So like a user of case tool can draw different diagrams, UML based diagrams. So what are UML diagrams? We already have been discussed in our earlier lectures as well. The most main advantage of this case tool is that it's centralized data with many supporting software tools which actually can generate different products for different purposes based on the same set of data. Like these case tools provides the advantage is that different products for different purposes based on the same set of data is produced by these kind of case tools which are actually surrounded by a data store, as we see in our previous slide as well. So here is a brief description about case tools. What are UML diagrams as well, we already have been discussed. And the advantage of this case tool is that as different products for different purposes based on same set of data is actually provided by the case tools. So here is this is another important aspect of case tools which are actually surrounded by a data store. So students, what are the different applicable domain areas of this repository architecture where we can use this architecture? This type of repository architecture is normally suitable for large complex information systems where many software components like clients need to access them in different ways. These are the different situations where we can use this repository architecture. Like we can also use this type of architecture where we require data transactions to provide the drive control flow of different computation as well. So these are the different applicable domain areas. Except these areas, we can also use this type of architecture where normally you use this pattern where you have a system in which large volume of information are generated that has to be stored for a long time. You may also use it in data driven system where the inclusion of data in the repository triggers an action or tool as well. So these are the different situations where we can use this repository architecture. So where we also have some advantages of this repository architecture as well. Like it provides us a components independence. Like they don't need to know the existence of each other components. Like change in one component can be propagated to all components. Like it also all data can be managed consistently, like different backups done at the same time at all in one place in a shared repository as well. So these are the advantages of shared repository model as well. So where we have some advantages, we also have some disadvantages as well. Like because we have a single data store, so there is a single point of failure is a main drawback of this repository architecture. Another drawback is inefficiencies in any organizations which lacks in any communication through this repository. So this is another drawback of this repository architecture. And the more important drawback of this repository architecture is that distribution of our main repository across several computers may be a very hectic work or a difficult task. So these are the most three main drawbacks of this repository architecture: single point of failure, inefficiencies in any organization in terms of communication through this repository, and the distribution of repository across several computers. So these are the three main drawbacks of this repository architecture. So students, still here our lecture number 22 is ended.